Hi, today I will review a few things that we learned the last semester. So let's start from the atoms. And on the atoms, we have some neutrons, protons, and electrons. So we should point to the electrons. Um, we should check something for the characteristics of electrons. Electrons has some energy, so every electron has some energy, and electrons should be located in the specific energy level. So there are each energy level for some electrons, every electrons, and the least energy level, the least electrons that is near the neutrons have the least energy. So yes, and then the first electron from the neutrons have the most big energy. Those among other electrons. So yes, we should know the specific characteristic of electrons, and if the electrons move to other energy level like jump up or fall down, the electron should get some energy or lose some energy. So if the electron want to jump up to the another energy level, that electron should get some energy from outside. But the electron which is want to fall down to underneath energy level, that electron should lose his energy. If the fall down happened, some light will be exposed. So yes, it will be used in LED, I think. And then let's talk about the Schrödinger equation. Schrödinger equation is used to calculate the wave function of material. So electron is material, and it moved by wave. So we should know about the wave function of electrons. So we use a Schrödinger equation, and based on the Schrödinger equation, we can know the 2 points. First is the potential well is proportional to the energy number. So yes, and then the potential well the width of the potential well gonna be bigger. The energy will be exponentially low. So yes, the width of the potential well can affect the energy. So we should know that those two things to calculate electrons characteristics. And then we can talk about the quantum tunneling. Quantum tunneling can happen in every material because they are based on the quantum mechanics. So yes, if the barrier is thick, quantum cannot tunneling that barrier, cannot move to the other side of barrier easily. However, the barrier is very thin. If the barrier is very thin, the quantum can tunneling very easily to the other side. So we should control the barrier, the thickness of barrier to move electrons. It is the also most important thing in quantum tunneling, I think. And then we should talk about the energy split. If there are potential energy in the materials, every materials, and potential energy has a negative energy. So if the two potential energy will plus, and then that potential energy will be gonna be lower than before, because those potential energies have negative energy. So we should know that characteristic to calculate potential energy. And then if the two potential energy plus will be plus, after plusing the two potential energy, the energy level will be splitted. Yes, it is. We called it hydrogen bonding in hydrogen atoms. So after the hydrogen bonding happened, the energy level will be splitted, and then the empty energy level will be obtained. So we can find the fully emptied energy level on the split after splitting, and we should check that energy level carefully, because it is the base theory of conduction band. So after splitting, we can find a valence band and conduction band. So let's talk about the theory of those concepts. Valence band is the edge of the edge which is fully occupied by electrons. So in the valence band, there are many electrons are located in that energy levels. However, conduction band is the edge which is fully emptied by electrons. So there are no electrons on the conduction band. However, there are some other energy band between conduction band and valence band. We called it a forbidden band, or energy band gap. So in that energy band, there are no electrons are located in that place, because there are no energy level placed in that band. So every electrons cannot be placed in that energy band. So we called forbidden band in, yes, forbidden band. So we learned about the conduction band and valence band theory. And then next we can talk about the movement of electron and hole. On the conduction band, there are many holes are located in that band, and also many electrons are located in valence band. So if the electrons have some energy, they can jump up to the other energy level. So after we give some energy, and that electrons can jump up to the conduction band. So yes, we can we can change the position of electron and hole. So hole gonna be fall down to the valence band, and the electron will be jump up to the conduction band. So it is the basic theory of the current happening. So after those electrons and holes move, the current will be made. So we should control the source or energy, giving energies to control the electron currents moving. So yes, it is the basic theory of how the current makes. And then we learned about how the current make, and then we should we should use to the other materials too. So let's talk about the other materials. And then materials, there are many sorts of materials in the world. So and then those every materials has different types and different energy levels. So we should check the EK diagram of each materials before we use it to our experiment. If when we check the EK diagram of that material, we can find the two types of energy band. First, it is the direct band diagram, and second is the indirect band diagram. So there are two types of energy band diagram on the materials. Um, Direct band diagram has many advantages between indirect band diagram, because if that material has a direct band diagram, it can move the electrons or hole very usefully, so effectively also. Yes, so we can lose lose less energy than other materials because they have same kinetic, same K energy, so it's same wave or something else. So that that direct band diagram has many advantages from other materials. However, indirect band diagram has a little bit bad things than direct band diagrams, because it when that materials want to move electron or hole to the other energy level, it uses more energy than direct band diagram materials. So yes, we should more give some energy or something else to move electrons and holes. So if you want to make the most effective device to use materials, you should use direct band diagram materials, I think. Yes. So and then let's more talk about the Fermi-Dirac and density of states. There are yes, we learned about the electrons and hole and how they can move. After learning that theory, use the we should use that theory to material. So we should know about the characteristic of electrons, because electrons can be located in the energy level, but other energy levels, those electrons cannot locate it in because they have probability. So the probability of electrons located in the energy level, each energy levels, means Fermi-Dirac, and each energy states or levels will be located in the material. The probability of the energy states is the density of states. So we should know the two concepts to calculate the probability of electrons, and then if we combine two things, Fermi-Dirac and density of state, we can obtain the Boltzmann tail. It means the probability of electrons can be placed in the material in each energy levels. So yes, we should check the Boltzmann tails and then use and then plan something else like how much energy that will give to the material, or how much thickness that use we should make by this material. So Boltzmann tail is the most important things of the basic theory of electrons, I think. So yes, today we talk about the many things like atoms, electrons, or yes, Venn diagram, energy band, and yes, Boltzmann tail, until Boltzmann tail. So yes, I review all about it, and then thank you for watching my video. Bye.